Hello everyone, in this video I'll be giving you a basic overview of a smart contract I created, and I'll just go through everything I've written here step by step, and I'm assuming that you're familiar with Solidity. So let's get started, and I'll also test this contract soon to to ensure trust maybe. Okay, no. So this is a contract to create this contract, and this has this function that has these parameters. These parameters are passed here, and then they're passed to the constructor that is here, right? And so this is a crowdfunding contract. This will basically allow anyone to get donations for a cause. So this mapping declares the contributors, and these are some variables: admin, number of contributors, minimum contribution, the deadline of the contract, and the goal of this contract, and the raised amount. So an struct for a request. Request will basically allow the admin, whoever creates this contract, the admin will be the MSG.sender who runs this contract. So whoever this admin is had to request the raised amount and draw it. And we have a voting system here, so this will let um, anyone, like this will let the contributors vote if they want the recipient to the admin to be able to withdraw the money. So let's get started. Okay. So this is struct. The struct has the description, the request, the description for the request, the recipient, whoever will get the request amount, the value, and a boolean whether the request is completed or not, the number of voters, and then this is a mapping for the voters. It's like if you are voted or not. Damn, I've made, I have messed up the names here somewhere, in some places. Then there's mapping. There's a mapping that beyond request. This this is maybe an array to create the requests, and these are a few events whenever an amount is contributed, whenever a request is made, whenever a payment is made to the request is made, whenever payment to the request is made. Then here's the constructor. The constructor should have a little here. Never mind. So the constructor, whoops. Yeah. So the constructor has the goal that is passed on from here, and then this goal, the deadline, and the address of whoever uses this contract. So this has a goal, and this goal is converted to ethers, and then this deadline timestamp plus deadline amount, and this admin is EOA, and the minimum contribution is 100 day. And here's the contribute function. Require timestamp should be smaller than deadline. So the deadline should now have been passed before the contribution is made. Require is MSG.value is greater than equal to minimum contribution. So the minimum contribution should be met. If contributors, so this checks if the user, the MSG.sender hasn't already contributed, and if the user hasn't, the number of contributors increase. Otherwise, the value is just added and nothing happens. Contributors message.sender plus equals message.value. These are the contributions of the message.sender of the user increases by the message.value, and the raise amount is plus equals msg.value emit, then the event is emitted here of the contribution. So So the amount is also added to the raised amount of x. Then there's a receive function which runs the contribute function here. So this is a function to just check the balance. I don't know why I added it. I could have just checked the raised amount. It's just a useless function. I'll remove it later. Function refund. This is something I'm a little skeptical about. I'm not sure. So refund. This allows the contributors to get a refund if the deadline has passed. If the deadline has passed, and if the raised amount is if the goal is not met. So yes, and require contributors.message.sender is greater than 0. This means that the contributors of the message.sender should be greater than 0. Yeah, they should have contributed to be able to refund, right? So address payable recipient is equal to payable msg.sender. So yes, and this event value is contributors msg.sender recipient.transfer value. So this actually just adds the recipient here, and the recipient, the value of the recipient's donations is declared here, is added here, and the recipient dot transfer value receives the value here, and the contributions of the industry.sender becomes 0. This is an only admin modifier for function that is supposed to be used only by the one who deployed this contract. Who deployed this contract, but you know what I mean. So this is a function to create requests that I explained what requests are before. So this adds the description which is in memory, and address payable recipient, which allows the user to the requester to set the recipient, and the value here is set public only admin. This uses the only admin modifier, that is. So recipient request storage new request num requests. Yeah, this just lets us access the request, and here's another and then we just add it to the number of requests, and new request dot description is equal to underscore description, which I put here, and the recipient, the value is also here. The new request dot completed status is false, and it's already false by default, and then new request dot number of voters is equal to 0. So yeah, a new request has no votes. So this is a request event here, and then there's a function, a vote function. This allows the contributors to vote on the request. So if the number of votes is greater than what is allowed, like if the number of votes is greater than 50% of, like 50% of contributors agree to this request and want the admin to withdraw the money, then then the request is allowed, right? So vote request is event underscore request number public. Require contributors.message.sender is greater than 0, so they must have contributed to make a vote request, and then we request the request and access the request. So require this request dot put this in stream. So they should have not already voted, and then we make it true, so they have already voted, and then we just add the number of voters, and then this is the final thing. Just lets then the requester withdraw the money. So this is a make payment function, and then there is event underscore request number public only admin require public. This requires that the raised amount should be greater than goal or equal to goal, and then the request storage this request should equals to request, then we access this request, and then we require this request not completed is equal false. So this request has been completed, require this request dot number of voters is greater than number of contributors divided by 50% of voters. Yeah. So this is the line. So this requires that the number of voters should be greater than the number of contributors divided by 2. So 50% should have voted for yes. Maybe can I also add an equal to here. So in this request dot recipient, then you transfer the request value, and the request is completed, and then the event is emitted. Oh, so we went through the contract here, and let's get into the testing here. So by deploy this, I'll deploy the funding creator first, the creator of this contract, and then from this account using JavaScript VM, 100 ethers all of them. So I deploy it here, and this is the funding creator, and this is just so I'll create here, and I'll make sure that the maybe I'll keep the target to 10 ethers, 10, and the block.timestamp I'll have to keep for I want it to be 2 minutes, right? So what's the time? It's 1:37 here. So let's it's 300, 600. Oh, why so dumb. So if I want it to be 2 minutes, I can add 120 seconds. So I think 3 minutes will be enough. So I'll add 180 seconds here. Let's just add 180 seconds. So this deadline is then, so you can see the deadline here. The deadline is added to the block.timestamp. So whatever the block.timestamp is, it's 180 seconds later. Is there anything else we need to do here? No. So we created a funding here, and we can just check the address of the funding here, the contract's address. And then what we do is we go, I think this will be the tool list, 240, we'll have 240 or maybe 300, we'll have 300 here, 300 into 5 or 6 into 5, so we'll have solid 5 minutes here, and this one is created, and we access this once, access this once, so yeah. Then we load this contract. Oh shit. I think I copied this.